You probably can't see me back here, but that's okay. It's not important. Less pressure on me then. So,
It just takes a second.
okay, so for those of you that don't know, my name is Charla, and I've been doing my PhD project here in Húsavík for about 3 years. And I'm looking at humpback whale entanglement in the fishing industry. So some of you have maybe heard about this before, but now I have some updated things to tell you as we're going through the results of the project. So I'll just go quickly, for those of you that haven't heard it before, a little bit about the background and then about the 4 kind of components of my project. So I'm looking at entanglement. It's considered one of the leading causes of human-induced mortality. And most of the time when people think about entanglement, traditionally they would think about the sad picture on the right of the dolphins or porpoises getting caught in the nets and drowning. But for large whales, that's often not the case. There's a lot of different impacts that particularly affect large whales besides drowning. So one of them is that we sometimes see here is rope injuries or lacerations from them being entangled before. Some of you who have been out there in the past days, you've maybe seen the whale that has the rubbing injuries, the raw injuries on it. That's most likely from some sort of net or rope that has been rubbing on the skin, and then they got rid of it, luckily. So that's something we see, and that is an infection risk. Also, some whales, they get entangled in the head region or the mouth, and it can disrupt their feeding. Whales that are carrying a lot of gear, especially if it's heavy or there's a lot of drag, it can change their energy budget. So especially for large whales like the humpback that are migrating long distances, it can disrupt their ability to migrate because they don't have the proper energy storage now to make that long migration. Also, an entanglement, it's a really stressful event on an animal. So it can cause weakening of the immune system and also possibly lower reproductive success for the females. So that's all not good news for the whale, but an entanglement is also not good for the fishing industry or the fishermen either. They have to repair net damage if they end up with the whales in the net. They have downtime to do that. And also it can cause loss of catch, of course. So all of that means that there is loss of money in the fishing industry. So it's not good for the fishing industry either. So in 2017, there was 1,621 active fishing vessels in Iceland. And there's been growing reports of whale entanglement and net damage. And there's also been a growing interest from fishermen, particularly from the Capelin fishery, about somebody looking into this for them and looking into if there's a way to minimize this problem for them. So for me, the first thing for everything that I had to do is I had to know which whale is which. So I spent a lot of time doing the photo identification of the humpback whales. There's estimated to be about 12,000 in the North Atlantic around Iceland, and there's roughly 800 just in the catalog here in Húsavík. So from there, the first thing I did was the scar analysis of the whales. So I was looking at how many whales basically have been entangled before, have scarring evidence that you can tell they've been entangled, and they've survived. So this doesn't have anything to do about the mortality of the whales, but about the whales that have been entangled in the Icelandic population. So this was developed in the US, and their protocol developed 6 coding areas around the whale. You can see 4 of them in the picture here, and then the others are just on the other side. Because humpback whales, the most likely place that they get entangled is around the tail. And then what I'm doing is looking for wrapping scars or notches or other things that are indicative of the whale being entangled before. So you can see sort of in the picture on the right, the arrows are pointing at some of the entanglement evidence that we're looking for in the pictures. This is just some examples of whales that we've seen specifically here in Húsavík. So the top whale, it looks a lot, the injuries look very similar to the whale that's out there right now. For those of you that have seen, that's Ray. that was here a couple years ago, and we actually, over the months, were able to see the whale healing. So it was interesting to see that. Sometimes we see whales with the gear still attached to them. So this was a few years ago. It looks like it's probably gill net wrapped around the fluke. And then we see like different stages of the healing, like on the bottom right, you see it's mostly healed, and you can see how the lines line up to the lines on the bottom. I don't know if you can see, but so you're looking for how the rope would be connected. And just like I was saying in that picture where you're looking for how they line up, so you have to have injuries indicative of an entanglement in 2 or more of the coding areas in order for it to be considered high probability of a previous entanglement. If there's only one, then it goes into the uncertain category. And if you couldn't tell that the scarring was from entanglement, then it of course goes into the low probability. So we did this for the Icelandic population. We had a sample of 379 usable whales, and based on that sample, it was basically 1/4 of the humpback whales in Iceland have been previously entangled at least once and survived. Some of them, there was evidence that they've even been entangled more than once in their life, but this is just at least once. And then we also could calculate an entanglement rate per year from this. And the more precise one was based on raw injuries. So if we saw a whale with raw injuries, we used that as a proxy for the whale has been entangled within the last year. And so it was 2% basically of the Icelandic population is entangled every year. And if you're more interested in all of the science of that, we published that this year in Endangered Species Research. The next thing I wanted to do is do a survey of fishers and gather eyewitness accounts. The fishermen are the most likely people to see an entanglement or see what's going on. It's considered something that's really rare to see. So they have knowledge that most of the time nobody else has. So I was trying to learn things like where were they, when, what type of gear, what type of fish were they fishing for, do they know what the whale species was, also do they incur monetary loss because of the whales, and also why or why not would they want to report to somebody if they had a whale in the net. So one of the interesting things from this is that there's fishermen reporting whales being entangled in all different types of gear, gill nets, purse seines, long lines, and also that they are incurring damage. And one of the captains that I spoke to, he said like the most serious incident that he had with his nets being destroyed, it cost him, he would estimate, around 48 million kroner. In terms of, is it necessary to report it or why would they not? I definitely got some answers just saying that they just don't think it's necessary. There's a lot of whales and it's just a lot of pressure on them for nothing. It's easier just to say nothing. Also because, of course, they're worried about shining the spotlight on themselves and worried about what's going to happen to the fishing industry if they speak up and tell the truth and say there's whales in the net. They're worried that they're going to be reprimanded for that. So in relation to that, another thing that we started doing was acoustic testing, acoustic deterrent testing. So we did experiments here in Skjálfandi and also in Eyjafjörður, and we were looking for responses of individual humpback whales to see if they behaviorally reacted to the pingers or also the seal scarer. So the whale pinger is designed specifically for humpback whales to try to warn them about the gear in the water. So that's more like a fishing gear application. Then I was lended a seal scarer that was being tested already on minke whales in Iceland to test on the humpback whales. It's traditionally used for, just like it says, to scare seals away from fish farm operations. But then it's also being tested for other applications, like if they can move animals away from an area before they're going to pile drive, for example, when they're building offshore wind farms. So basically what I had to do is find a whale alone, which was already not that easy in the end. And then I had to, basically we followed the whale half an hour before, 15 minutes with the device in the water, and then half an hour afterwards. And then we were able to compare the before, during, and after to see if the whale changed its behavior. And so then we were, I could calculate the breathing rate, the diving time, the whale's position on the track, which then you can get a directivity index of how straight or how not straight the whale was swimming, and also the speed of the whale. So maybe I don't have time to show you, but this is basically what we were doing. It's really easy. We were just had to be out when it was very calm, and then we had the drone once, thanks to Jan, so we were tracking the whale with the drone sometimes also. Another thing that we looked at for the whale pinger in the end is I had a student go through the videos that we took, and we were looking for feeding behavior so that we could see if they changed the feeding behavior before, during, and after. So basically we're looking for this for lunge feeding or with the expanded throat pleats so that you could tell that the whale was feeding.